Welcome everybody to the sub-lesson for January 23rd, 2024. I wanted to go through a lot of this material just to support you. Now the idea is for you to develop an understanding and a recognition of these things yourself. I don't want to do it for you. I don't want you to follow through and just copy what I have. That's not going to help you learn. What you want to do is try it out yourself. So I recommend these 3 steps. First, look at a problem and think about it for yourself and recognize some properties about them. Then use those properties to help solve problems. We'll see it in this first problem in just a second. Secondly, if you're like, I can't recognize what property this is, or how do you use that? Talk to your group and be like, hey, what do you do? How do you think we could solve this problem? Oh, that looks like opposite sides need to be congruent, right, in a parallelogram. So I'm going to use that property. Oh, if they're congruent, that means I can say that their lengths are the same, that they're equal. So I can write an equation, and then I can go ahead and solve that equation. So you want to develop that understanding. Now, if you are getting stuck and you're like, okay, I'm using the properties correctly, I'm finding out that I can create the equation, but I'm getting stuck in my algebra, I'm having a real hard time solving the equation, that's okay. Create the equations. Now, on a test, if you had to do something like that, as we talked about in geometry, getting to that equation is the thing that gets you to a C. What you need to do is then think about that equation and go ahead and solve and go further than that. Okay, so ask your group and then finally go back to this video to get some help if you're really having trouble. All right, so I'm not going to be giving you full solutions, by the way. I'm going to be giving you guidance in each problem. Let's start off with this first one. Example number 3. For what values of R and S is WXYZ a parallelogram? Well, as we look at this, for it to be a parallelogram, opposite sides need to be congruent. So that means this side and this side need to be congruent. This side and this side need to be congruent. Oh, opposite sides are congruent. If I keep those properties in mind, I'll be able to develop an understanding. And remember, congruent means that they're going to be equal. So that allows us to create some equations. Now again, I'm going through this first problem with you, but I will not go through all of them directly like this. So I can look at the top and bottom, and I know that they're supposed to be congruent. So I know S plus 5 is equal to 2S minus 2. Now I've got to do my algebra and solve this equation. Let me just adjust that. There you go, 2S minus 2. And you'll notice my 5s are really bad, so I'm going to change that 5 to be a much more clear 5. S plus 5 is equal to 2S minus 2. So in order to solve this, I want to get the S's on the same side and then get the numbers, the individual numbers on their own. So I'm going to subtract S from each side, and I'm going to add 2 to each side. Okay, what that does, that cancels out my 2, and then I have 2S minus S. So 2S minus S is going to be just 1S left over. Okay, I could put a 1 in front of it if I want, but I end up with S is equal to 7. So this is what my S value should be. And I can plug that in if I wanted to and actually find the measurements of the angles. Remember, we never really solve just to get a letter. We want to solve so we can plug it in and get the measurement of an angle. If S was 7, this is going to be 2 times 7 minus 2. And this would be 7 plus 5. So this is going to be 12, and this is going to be 12. In both cases, it's 12 because they're supposed to be congruent. In the same way, I can create my equation with R's, and I'm going to do that with a slightly different color. 4R plus 7 has to be equal to 7R plus 1. Again, go ahead and solve it by putting the R's on one side, putting the 7s, or the regular numbers, on the other side. So I'm going to subtract 4R from each side, and then I'm going to subtract 1 from each side to get the numbers over there. 7 minus 1 is 6, and 7R minus 4R is 3R. So I get 3R is equal to 6. Let me actually change the color of this real quick to be pink. There we go. All right, so what do we do next? Well, we've got to get rid of that 3, so we divide both sides by 3, and we end up with r is equal to 2. So we get 2 is equal to r there. Plug that in. 4 times 2 plus 7, which is 8 plus 7, that's 15. 7 times 2 plus 1, which is 15. Okay, again, we didn't have to plug it in because we knew that they were congruent. The second time, once we got the first one, we knew that this was going to be 15. All right, so I'm going to talk about the properties on each of the next problems and think what property is actually valid here. What's the property that you want to use? And you're going to go through and use those properties, but I want you to try to recognize the properties yourself. This problem is just like the last one on example B. You're just dealing with angles, so you got to find the measures of the angles. And so the property that we would use here is that opposite angles are congruent. Okay, use that to solve that problem. Okay, create some equations with it and then see if you can solve the equations. Now here, it provides a similar kind of issue, but it gives you what the x and the y value is. So here you got to actually plug them in and see if that statement is true. And this is the same statement that's up here. Opposite angles are congruent. Is that true? Our opposite angle is going to be congruent here. All right, here, if G and H is this a parallelogram? And again, that comes from the opposite sides are congruent. So notice how we're using very similar things and just practicing them in different ways. Here you've got to plug in G and H and determine, are they going to be congruent if you plug them in? Will it be a parallelogram? Example number 4, is this proof? Now, if you are brave and you want to try a proof, go ahead and try it. If not, we will be doing this proof on Wednesday. This is one that you're going to be doing yourself. So I would recommend you go ahead and try it, but if you are a little afraid of proofs, you don't like writing all those things, or you're afraid of it, don't do it. Go on to the actual other problems that you really need to practice. All right. For what values of P and Q is it a parallelogram? So this is going to require that's other property because these are the diagonals. So since these are the diagonals here on try it number 4, we want to go ahead and use the idea that in a parallelogram, the diagonals bisect each other. Okay, recognize that the diagonals dissect each other. All right, next problem. And if the diagonals bisect each other, create the equations, solve for them. This next question says, is this a parallelogram? Ooh, good question. Now we have 2 congruent sides. So that looks like it could use the opposite sides are congruent one, but remember we need 4 pairs of congruent sides. We don't have 4 pairs, we only have 2, but we do know that this combines to form 180 degrees. So we have opposite sides are congruent, but then we also have this adjacent angles are supplementary here. Does that together make parallel lines? Well, since we know what these angles are, and we know that these lines are congruent, we know that the distance from this angle to this one is going to be the same. So I want you to use those 2 properties, and I'm going to write them down. Opposite sides are congruent and adjacent angles are supplementary to solve this one. Okay, for this one, I want you to use the diagonal property. If you're starting to recognize, oh yeah, this is dealing with the diagonal, so I got to use the diagonal kind of property. And I have it written right over there, so I'm not going to spend my time rewriting it. In a parallelogram, the diagonals need to bisect each other. So if they do, that's great. All right, going on to this problem. Is it a parallelogram? Ooh, well, we've got two opposite angles that are congruent. Well, does two opposite angles being congruent, does that imply that it's a parallelogram? Not exactly. All right, next one. Is EFGH a parallelogram? Well, again, this goes right along with that previous problem right up here. Is this one a parallelogram? Well, opposite angles are congruent, adjacent angles are supplementary, and opposite angles are congruent. Using both of those, could we show that it's a parallelogram? Go ahead and try this just like you tried that previous one. All right. Now, let's go to example number 6. Mechanic raising a truck using a lift. For safety, the floor must be horizontal. The top of the lift must be parallel to the floor as the lift is shown in a safe position. In other words, is this a parallelogram? And this goes right along with our last two problems. It's really using the same thing. Opposite sides are congruent, adjacent angles are supplementary. Does that make it a parallelogram? All right. For the try it, we have the same structure that we're looking at. The same structure as this problem. As a problem here, that the diagonals bisect each other. So is this true in that problem? Okay. And notice you can see the diagonals right here. All right. Lesson 6.5. These are a set of problems you don't need to really answer to develop your understanding very much. What they are is just an investigative task. Useful, but not necessary. All right. Then we're going to get to our special parallelograms that we talked about yesterday in class. So is this one a rhombus? Well, take a look at it. Does it have that defining feature of a rhombus? And the defining feature that you're looking for a rhombus is that it has 4 congruent sides. This question isn't, is it a rhombus? It says it is a rhombus. What's the measure of those 3 things? And in order to think about that, I did answer the question wrong already. In order to consider that, what you want to do is actually look at this figure. Since it's a rhombus, what do we know about parallelograms? And so this goes with that diagonals bisect each other. Okay, so we know that diagonals bisect each other. And so if they do, what does that tell you about each of these triangles? And this kind of connects with our proofs, because a lot of times in the proofs, actually all the time in the proofs, we're trying to find congruent triangles. And then once you have congruent triangles, think about what that implies for these angles in the middle. Okay, for this next one, the parallelogram is a rhombus. So what does that mean? What extra properties does it have? And again, here we have a rhombus. So we're going to be using a specific property with the rhombus. And that specific property that you're going to look at is, since a rhombus is a parallelogram, what do we know about opposite sides? Opposite sides are parallel. Okay, we know that opposite sides are parallel. So what does that mean? Think about all of the things that happen with parallel lines. It's alternate interior angles, corresponding angles, etc. All right, next one. What is WY? Here you want to find out WY. Now this one's a little harder to do. And so with this one, I'm going to kind of quickly talk to you guys about it. Now, we know that this is a rhombus. 4 congruent sides. So we know that those lengths are preserved. That means this is 5. Ooh, if that's 5 and this is 3, what's this length? Because that's part of WY. We need to find that length. And in order to do that, we would use the Pythagorean theorem. A squared plus 3 squared is equal to 5 squared. And here's our A. All right, solve for A, and we end up with A squared is equal to 5 squared minus 3 squared. And A squared is equal to 25 minus 9, which is equal to 16. So A squared is equal to 16. A is equal to 4 because it's a distance. So we know that A is 4 using the Pythagorean theorem. Okay? With knowing that, we can go ahead and find out WY using, again, that special property about the diagonals in a parallelogram. The diagonals bisect each other. Okay, those diagonals bisect each other, so WY is equal to 8. That's because if that's 4, this is also going to be 4. All right. What about this one? Well, you might see some relationships between the triangles again. Again, building up in that understanding so you can make a proof. If this is 70, what's the measurement of that? Okay. Oh, and what is the measurement of RPS? For this, I want you to think about the fact that it's a rhombus, the fact that you've got some congruent triangles. Think about what the shortcut is for those congruent triangles. And then finally, so you've got congruent triangles, you've got a rhombus there. You've got congruent triangles. In addition, you have a special type of triangle. Notice this triangle. And we've got isosceles triangles. Okay, so use that to find the measure of this angle. You're trying to find this angle right here. That one. Okay. All right, let's keep going. We're on page 19. So here's a rhombus. What's the measure of angle ADE? Let's go ahead and find it. ADE is this angle. So, like with the last one, we're trying to find this angle. So you might need a property of rhombuses, a property that you're kind of learning about rhombuses, but you also can see it over here. Okay? So use that property of rhombuses to find that missing angle. You want to find that angle there. Now, a big property of rhombuses that you want to use is you've got some congruent triangles. Make sure to find out what shortcut allows them to be congruent. You should also use the parallelogram property that the diagonals bisect. Now, if you've got congruent triangles, then we've got CPC, Those parts of congruent triangles are congruent. So use that and the trisum theorem. All right, next one. Here, quadrilateral GHJK is a rhombus. Ooh, and you want to find out the length of x. It says, what is, add an x to the end of that. It's written on this, or what is GH? Sorry, not what is h, what is GH? But GH is in terms of x. So, we know that GH is here. So what can we do in order to find it? Ooh, looking at that. We know that this is 3x plus 1, so that's the same. We know that this is related to it, and that's something that you can look up using one of these rules up here. Okay? All right. With our next one, the quadrilateral is a rhombus. What's the measure of angle MNO? So let's go ahead and make sure we know where that is. What is the measure of angle MNO? This big angle. So because it's a rhombus, you've got some special properties that start to show up. So use that knowledge to do it. and it's very similar to what we used here. Okay? And this says, what is QT? For some reason, those next lines just did not change their font well. What is QT? All right, so QT is just this distance. So just like with the other ones, you're going to want to use the idea that diagonals bisect each other. You're going to want to use some congruent triangle relationships. Notice here, and just in case you had trouble with this one, notice this distance and this one are part of those diagonals bisecting. Maybe you'll be able to solve for something knowing that relationship. And then plug it in, and the same is true for here. These go right next to each other for that. Here's another proof. If you are brave enough to try it, go ahead and try it. I'd really recommend that you try on your own a little bit, but if not, go on to try it. Number 3. Okay, the carpenter needs to check the gate his apprentice built to be sure it's rectangular. The diagonals measure 52 and 53 inches. Is the gate rectangular? And one of the special things about a rectangle is that the diagonals are congruent. So is it rectangular? Think about that to answer that question. In a rectangle, and this is an extra property you may or may not have. I went through that extra property with about half the classes. The diagonals are congruent. And this is for a rectangle, not for another figure. All right. Did he make the goal? Paul's training his horse to run the course at a pace of 4 meters per second or faster. So he goes from D to C, and then C to E, and then to B in 1 minute, 30 seconds. It's a rectangle. So what was his distance? Now, in order to answer that, you're going to want to do something, and this is one where really help will really come in handy. You want to think about what this distance is. Now, if that full distance up and down is 80, what's this distance? Well, remember a rectangle has these diagonals being congruent. That means this is going to be exactly half of that. And we can also go ahead and do the same thing here. Make a right angle there, make a right angle there. It's going to be exactly half. And if you use some Pythagorean theorem, you'll be able to get the measure of this angle. Okay? A rectangle with an area of 1,600 meters squared is 4 times as long as it is wide. So with this one, you're going to want to use an area shortcut. Use area. And it's 4 times as long as it is wide. So if we know that its wide is x, then its long is 4x. And altogether, it equals 1,600 meters squared. So knowing that it's 4 times longer, go ahead and do some multiplication and find out the measurement of it. And then use that to get the sum of the diagonals. Because in this problem, it doesn't say just get the diagonals, it says get the sum of the diagonals. All right, you might want to use a right triangle Pythagorean theorem once again. So area, Pythagorean theorem, etc. All right, this is a square. Wx, or Wy, and xz is equal to 92. So what is the area of WPZ? So I know that these two lengths together equal 92. So what I'm going to do is I'll cut it in half to find out the length of 1/2 of it, because the diagonals are going to be congruent. It's a square, so it's a rectangle and a rhombus. So since it's a Rectangle, I know that these two diagonals are congruent. So if this was 92, then that means that either one of those is going to be 46. And so since they're both 46, what's the length of part of it? And then use that and a hypotenuse to create an altitude. All right. For the remaining problems, I want you to work on them. I feel like this video is getting pretty long, but I want you to work on them recognizing what parallelogram properties do they display? What can you conclude about the shapes? Okay, what do you know about the shapes just from the evidence that we're given? Can you get something more specific than certain things are congruent or certain things are parallel? Some of them require special results. Okay, so in each of these, think about which ones are parallel or which ones fulfill a property of a parallelogram or something else. With that said, I'm going to bring this video to a close. I hope you guys have a good day in class, and I can't wait to talk to you tomorrow about your success.